Welcome to the world of Elasticsearch, where search and data storage collide to revolutionize your information retrieval. Have you ever wondered how vast amounts of data are seamlessly searched and retrieved in milliseconds? Imagine a virtual library where finding a book is as quick as snapping your fingers. With Elasticsearch, this reality is not just a dream, it's the present. By combining lightning-fast search capabilities with robust data storage, Elasticsearch opens up endless possibilities for efficiency and insight. Today, we embark on a journey into the fundamentals of Elasticsearch, unlocking its power for your benefit. Fasten your seatbelts as we delve into the heart of search and data management with Elasticsearch. What is Elasticsearch? Imagine a highly efficient library system, but for data. Elasticsearch, a distributed, open-source engine, is like having an intelligent catalog that swiftly retrieves information based on your criteria. It offers lightning-fast search capabilities, scales seamlessly from one machine to hundreds, and provides real-time data accessibility. With millisecond response times even for vast datasets, Elasticsearch is a powerful tool for log analytics, monitoring applications, and business intelligence. It's the go-to solution for storing, searching, and analyzing large volumes of data quickly and effectively. In Chapter 2, we delve into the core architecture concepts of Elasticsearch. To grasp how Elasticsearch functions, we must first comprehend its foundational elements. Shards are the partitions of an index housing documents, while indices are the logical collections of these documents. Nodes, the individual servers in a cluster, come together to form the entire cluster, a collection of nodes working in unison. Picture a cluster as a team, with each node as a dedicated player. Indices are akin to databases, organizing collections of documents with shared traits. Shards then divide these indices, facilitating horizontal scaling across nodes. At the heart of it all lies the document, the fundamental unit of information expressed in JSON format. And so, as we unpack these core concepts, we lay the groundwork for a robust and flexible search system. Ever wondered how Elasticsearch makes searching lightning fast? It's all about indexing. When you submit a JSON document through the API, Elasticsearch analyzes the text, stores it in a shard, and updates the inverted index for speedy retrieval. Think of the inverted index like a book's index. It lists all the important words and shows you which documents they appear in. So, next time you search for something, remember that Elasticsearch's indexing magic is at work behind the scenes, making finding information a breeze. Ever feel like searching through a massive database is like looking for a needle in a haystack? Traditional methods have us sifting through rows, one by one, which gets sluggish with mountains of data. Enter the inverted index concept. Imagine a magical lookup table in Elasticsearch where each word leads you directly to all the documents it appears in. So, instead of scanning row after row, searching becomes a lightning-fast lookup operation. Need info on database? Just zip to the relevant documents in a flash. This efficiency, regardless of data volume, is a game-changer. Elasticsearch organizes data smartly, tying words to their document homes for swift access. Say goodbye to slow searches. With an inverted index, speed and scalability are the new norm. Ever wondered how searching actually works in Elasticsearch? It's not about scanning every document. Instead, the inverted index swiftly pinpoints the relevant ones. The process unfolds: a query received, parsed, terms looked up, documents scored, and the top results returned. Users send their search request, queries get analyzed and split into searchable terms, then the inverted index comes into play across shards. Documents are scored using relevance algorithms, and finally, the top-scoring ones make their way back to the user. Think of it like a well-oiled machine, efficiently delivering the most relevant information at your fingertips. And that's how Elasticsearch makes searching a seamless experience, cutting through the clutter to serve you what matters most. Ever wondered how Elasticsearch handles basic database operations? In Chapter 5, we delve into CRUD operations. Just like traditional databases, Elasticsearch allows you to create, read, update, and delete data. However, here's the twist: these actions are executed through RESTful HTTP APIs, using JSON for data exchange. Each operation is directed at a specific index and document ID. To create new data, you make post or put requests. When reading, get comes into play for fetching documents by ID or through queries. Updating involves modifying existing data partially or entirely with post requests. And when it's time to bid farewell to certain data, simply use the delete request. Remember, all these actions are carried out using HTTP methods and communicate with JSON. So, whether you're adding, retrieving, updating, or deleting data, Elasticsearch has got you covered. Ever wondered how a document is created in Elasticsearch? It's as simple as sending a JSON object to a specific index. You can either let Elasticsearch generate an ID for you or input your own. Let's walk through a real-life scenario, indexing a student record. By issuing a put request to /students/_doc/1, we input details like name, age, major, GPA, and enrollment date. The response confirms the document's creation in the student's index with the ID 1. This process not only stores the JSON data but also makes all fields searchable, with version tracking for updates. In essence, each piece of information seamlessly slots into Elasticsearch, ready to be discovered. Ever wondered how we interact with data in Elasticsearch? Let's delve into the essential operations: read, update, and delete. To retrieve a specific student's information, we simply issue a GET request with the student's ID. When it's time to make changes, a POST request with the updated data suffices, targeting only the fields that need modification. And when we're ready to bid farewell to a record, a delete request ensures its permanent removal from the index. Remember, behind the scenes, an update in Elasticsearch is essentially a delete and recreate maneuver cleverly masked by the API. Streamlined and powerful, these operations empower efficient data management. In the intricate web of Elasticsearch, document structure is key. Each document, a JSON object, holds fields and values. No rigid schema constraints here. Diversity reigns as fields can vary between documents within an index. Yet, consistency is crucial. Fields with shared names demand identical data types. Take, for instance, a sample document, a student profile teeming with details. Strings like CS20240001 and Alex Martinez, numbers for age and grades, arrays listing courses, objects nesting grade specifics, and booleans for activity status. This rich tapestry of data forms the backbone of Elasticsearch's flexibility and power. Ever wondered about the secret information stored within your documents in Elasticsearch? Beyond your own custom fields, Elasticsearch automatically embeds metadata fields to each document. These fields, indicated by an underscore, reveal crucial details about the document's essence and status within the system. The underscore ID serves as a unique identifier, while underscore index specifies the containing index. As for underscore version, think of it as a number that elevates with each update. Delve into underscore source to find the original JSON document, and consider underscore score to gauge relevance during searches. Lastly, ponder underscore type, the document's type, which has seen its prominence wane in recent versions. These metadata fields are the unsung heroes of your Elasticsearch journey, providing a deeper understanding of your data. Mapping in Elasticsearch is like the schema in relational databases but more flexible. It determines how documents and fields are stored and indexed. Dynamic mapping lets Elasticsearch auto-detect field types, like text or keyword for strings. However, explicit mapping allows you to define types upfront for precise control. For instance, you can specify text for names, integer for ages, and float for GPAs. This hands-on approach optimizes indexing and searching. So, whether it's dynamic or explicit mapping, Elasticsearch offers flexibility and performance tuning for efficient data handling. Ever wonder how data is structured behind the scenes? Let's dive into the world of common field data types. Text fields hold full-text searchable strings like computer science, while keywords store exact match strings like email addresses. Numeric types like long, integer, and float are vital for math operations. Dates are managed with the date type, accommodating various formats. Boolean fields handle binary states like true or false. Objects contain nested JSON data, adding complexity. Remember, use text for search and keyword for filtering and aggregations. Data types are the building blocks of efficient data storage and retrieval. Ever wondered how Elasticsearch makes sense of all that text data? Enter analyzers, the core of Elasticsearch's full-text search functionality. Analyzers work their magic by processing text fields, converting raw text into searchable terms using character filters, tokenizers, and token filters in a seamless sequence. Picture this: character filters clean text by stripping out HTML, token filters normalize tokens by lowercasing and stemming, while the tokenizer breaks text into digestible tokens like individual words. It's a dynamic trio working behind the scenes to optimize your search experience. From cleaning and transforming text to modifying tokens and breaking text into manageable terms, analyzers are the unsung heroes of Elasticsearch's search prowess. In this example, we witness the analyzer in action. From the input text, the quick brown foxes are jumping, we progress through the tokenizer, token filters, and stemming filter. The processed tokens, like quick and jump, are what populate the inverted index, enhancing search capabilities. This method streamlines information storage and retrieval, optimizing search results for users. Ever wished you could speak to Elasticsearch in a language it truly understands? Enter Query DSL, Elasticsearch's JSON-based powerhouse for crafting intricate searches. Forget SQL, here, JSON reigns supreme, handling full-text searches, filters, sorts, and aggregations with finesse. Picture this: match query for pinpoint accuracy, term query for exact matches, range query for value boundaries, and bool query for logical query marriage. No need for translation, just hit _search, and voila! Get ready to wield the language of Elasticsearch like a pro. Ever wondered how to find students majoring in computer science with a simple search? Just use the match query in the Query DSL. But what if you need to narrow down your results further? Enter the bool query, a powerful tool that lets you specify multiple conditions. Imagine effortlessly pinpointing active engineering students with a GPA of 3.5 or higher, all in one go. This is the magic of combining different query types. Precision meets efficiency in the world of Elasticsearch. Ever wanted to pinpoint students within a specific age range or find a student with a unique ID? Range queries allow you to filter data based on numerical values like age, while term queries provide exact matches for keyword fields, such as student IDs. By employing GTE4 greater than or equal and LTE4 less than or equal, you can precisely define age brackets. For specific identifiers like student IDs, the term query ensures an exact match without any analysis. Remember, use term for IDs and match for free text descriptions, each serves a distinct purpose in querying your data effectively. Let's put our Elasticsearch knowledge to the test with a mini exercise. First, create a books index with specific mappings for title, author, year, and ISBN. Next, index 3 books with all the required details. Then, write a match query to find books by a particular author and a range query to filter books by publication year. Challenge yourself by combining these queries to search for books by author within a specific year range. For an extra challenge, try updating a book's publication year and deleting a document by ID. Practice makes perfect, so dive in and reinforce your Elasticsearch basics with this hands-on exercise. What makes Elasticsearch stand out? It's a high-speed, scalable search engine leveraging inverted indices for rapid full-text searches across vast data pools. Documents, stored as flexible JSON with fields and values, offer automatic or explicit type mapping. CRUD operations become a breeze with RESTful HTTP APIs, enabling easy document manipulation. Analyzers work their magic by transforming text into searchable terms through character filters, tokenizers, and token filters. Dive deeper into powerful search capabilities with Query DSL, a JSON-based language supporting complex searches. Ready for the next level? Explore aggregations, complex mappings, and cluster management to elevate your Elasticsearch expertise.